This is our video for lesson 4.4. So we're going to talk about scatter plots and lines of best fit. So before we start, we're thinking about what is a scatter plot. And it's going to look something like this. We have our axes, and there's going to be points kind of spread around. So we say this is a group of points that show a relationship of two variables. So for example, each dot on here could represent like a person where this is their height and this is their age. So this would be a person with a lower age who was very tall. This would be a person who was older but is shorter. And up until now, everything we've dealt with has been pretty much a straight line. And notice these are kind of more spread out. We will think about this whole line of best fit, meaning if our data is kind of in a straight line, what line would look best? But our data is going to be a little bit spread out to start. We're going to use these same equations that we have been using. We'll need to figure out the slope of our line of best fit and then write an equation using the forms that we've already talked about. So let's look at example 1. So this is looking at a scatter plot. We're talking about the amount of sugar and number of calories in different smoothies. So each one of these points represents a smoothie that has some number of calories and some amount of sugar. So part A, how many calories are in the smoothie that contains 56 grams of sugar? So if we want to find this, we'll just find 56 on the sugar. I'm going to go up until I find that dot, and then if I go over to the side, that'll show me how many calories. So just like we would on a, if this was like a coordinate grid and this was a point, we're just finding the x and the y values of that point. If I give you one of those values, you can find that point and then trace to the other value. So this should be 270 calories. How many grams of sugar are in the smoothie that contains 320 calories? So now we're going in the other direction. I'm telling you it's 320 calories, so we can find that point and then go down and find the grams of sugar, 70 grams of sugar. And part C is asking about kind of what's happening, what tends to happen to the number of calories as the grams of sugar increase. So what that means is I want to kind of look at the graph in this direction as sugar increases. So as I look at points that where the sugar is increasing, what tends to happen to the number of calories? And this is where we might kind of just want to think about the trend of the data in general. They're kind of going in this direction if we're thinking about a line that would kind of best fit this data. And since this line is going up and to the right, that tells us as the sugar increases, the calories are also increasing. So we would want to say something like this. As grams of sugar increase, calories tend to increase also. And notice this idea that they tend to increase is really important because they don't always increase. For example, like these 4 points right here, these are 4 smoothies where if we think about the sugar increasing, but the calories are staying exactly the same. So this isn't something that always happens, but it is a tendency. That's kind of the way that our data in general goes. We kind of have 3 different ways that our data can kind of look or go if we're talking about the patterns of our data. And I'm actually going to go in reverse order here. This one is going kind of up and to the right like we just looked at. If we were going to make a line that kind of best fit this data, we'll talk more about precisely how to do that in a minute, but it might go like this, kind of through the middle. And since it's going up and to the right, we call this a positive correlation. And it's positive just like slope is positive. If we're going up and to the right, that's positive. If we look at the next one, daily temperature compared to number of coats sold, the trend of our data is going like this and going down. It makes sense. As the temperature gets warmer, we're probably selling fewer coats. This, if I were going to draw my line, again, we can kind of try to split the data here. It might look something like this. And going down and to the right, just like down and to the right, that's a negative slope. We call this a negative correlation. In the next one, we're looking at person's age versus the number of vehicles they've owned. And it might kind of make sense that there's not really much of a pattern here, right? I couldn't really draw one line that's going to best fit this data. Maybe just a flat one might honestly be the best line. And we might remember that that has zero slope. This has no correlation. Okay, so if it doesn't really make sense to fit a line to it, it's not clearly positive or clearly negative, then that is no correlation. Moving on to our final example, we are going to write the equation for a line of best fit. And we're going to start with a little bit of information here and just kind of read this first and think through the process, and then we'll actually do it. So this says our table shows the total number Y in millions of subscriptions to a video sharing website, X years since 2010. Okay, so this is years since 2010. So this would be 2010, 2011, 12, 13, 14, 15, 16, 17, and 2018. And in each of those years, we had 9 million subscribers, 21, 26, 33, and so on. We want to write an equation that models the total number of subscribers in the year since 2010. Interpret the slope and the y-intercept, meaning what do these values mean in context? So here's kind of the steps we want to take. We're going to first make a scatter plot of our data. So let's just go ahead and do that. I've got this laid out, so I've got my x values on our x-axis, y values on our y-axis, and we're just going to plot this as close as we can to the actual value. So 0, and we've got 9 million subscribers. So I'm realizing that my subscription, I'm going to have to change these values a little bit here. So this should actually be 20 million, 40, 60, 80, and 100 million. So at 0 years, we have 9 million, so it's just above the 10. We've got 1 year and 21, 2 years and 26, 3 years and 33, just above the 30 there, 4 years and 43, 5 years and 53, now we're picking up a little bit, 6 years and 71, 8 years and 89. Okay, so here's a pretty good look at our data. Number 2, if the data is linear, continue to step 3. In other words, if it makes sense that I could draw a line that would contain most of this data, which it looks like I can, then we're going to go ahead and do that. We can write the equation of a line. First, we're actually going to draw a line that fits the data best. And we want to make sure that there's approximately the same number of points above and below the line. It's not always going to work out perfectly. And if we can, it's going to work out really nicely to draw the line that maybe goes through 2 of those points. I'm just realizing I missed one of my data points as well, 7 and 76. So here we go. Let's see if I can draw a line that fits this data pretty well. So this isn't bad. I think I'm going to move this just a little bit. There we go. That's pretty good. So now I've got 1, 2, 4 data points above, 3 data points below, and it's actually going through these 2 data points pretty nicely. And so what we're going to do is we're going to use those 2 to write our equation. Okay, so that's step 4. Write an equation using 2 points from the line that you made. So it goes through these 2 points at 2 and 7. So that's these points right here. And this should be what we've already done in the past. We've got 2 points. We've got an x and a y. We've got another x and another y. So just like we've done before, we're going to find the slope, and then we're going to write the equation of our line. So the only stuff that's really new is just plotting these points and drawing a line. So slope, 76 minus 26 over 7 minus 2. So this should be 50 over 5. 50 divided by 5 is 10. Its slope, I always like to think of that as a fraction. So we've got our rise over run. And then we're going to plug that in to our point slope form. And it doesn't really matter which set we use. I'll just use 2 and 26. So y minus 26 equals 10 times x minus 2. And we need to interpret slope and y-intercept. So let's get this into y-intercept form, and then we'll do that interpretation. So y minus 26 equals, I'm going to distribute that 10x minus 20. Add 26 to both sides. Y equals 10x plus 6. So now we've got our slope and we've got our y-intercept. So what do these things mean? Okay, so the y-intercept is always the point that's on the y-axis. So that is 0, 6. So in terms of our situation here, that would be in the year 2010, there were 6 million subscribers. Okay, that is the interpretation of our y-intercept. That's what that point is, 0, 6. So let me just write that one right here. In 2010, there were 6 million subscribers. And then to interpret the slope, so that's 10 over 1. So we're going up 10 over 1, up 10 over 1, up 10 over 1. So what that tells me is every 1 year, we are increasing by approximately 10 million subscribers. Each year, we increase by approximately 10 million subscribers. There we go. And this is always going to be the same way. Okay, when we interpret the y-intercept, we're always looking at when our x value is 0, what is our y? And we're just going to put that into words based on what that is. And then when we interpret our slope, it's always going to be an increase in this variable is linked with an increase in this other variable, whatever that slope is. For example, ours was 10 over 1, so every 1 year we increase by 10 million subscribers.